Polynomial functions. Okay, let's bring this all together. We've done a number of video lectures on polynomial functions and zeros, and the objective for this video lecture is to bring all that together. We want to find the real zeros of a polynomial function. In other words, we want to solve the polynomial, okay? So let's talk about all those things that we've done up to now that are going to come into play in solving the polynomial. Okay, so what do we know? We know what a polynomial function in one variable is. It's a function of the form f of x equals a sub n x to the n, etc., highest degree first, count your degrees down, a sub 1 times x, plus a sub 0, which is the constant. Okay, within this, what's going to be applicable? That the n here is the function's degree, okay? And the function's degree is equal to the maximum number of zeros, the maximum number of solutions, okay? We know the rational zeros theorem from a previous video lecture. If a polynomial function written in standard form has integer coefficients, then any rational zero, any zero that can be written as a fraction, must be of the form plus or minus p over q, where p is a factor of the constant term and q is a factor of the leading term. Again, here's the constant term, and here is the leading. Whoops, come on down a little bit. Here's the constant term of our polynomial, and here's the leading term of our polynomial function. Okay, we know the factor theorem, number 3 here. Okay, when f of c, when f of a number is 0, then x minus c is a factor of the function f of x. It goes into it evenly. It has a remainder of 0. Okay, and there's a remainder right here. Vice versa, you can go the other direction. When x minus c is a factor of the polynomial function, then f of c equals 0, which tells you that the remainder, if you were to have done long division, is 0. Finally, we're going to go back and see a little bit about with quadratics here. Okay, a quadratic, we know, is a polynomial of degree 2. Okay, and we can factor quadratics. We've done a lot of that. We can use the quadratic formula. We can use completing the square. We can use square roots, etc. There are 2 or 3 other methods that we can choose to use when we look to factor quadratics. Okay, so what are the steps to solving a polynomial function or to finding the real zeros? Number 1, and we'll do a couple of examples. Step 1, use the polynomial's degree to determine the maximum number of zeros. Number 2, if the polynomial has integer coefficients, and in our examples it will, use the rational zeros theorem to identify those rational numbers that can potentially be zeros. Okay, number 3, we're going to graph it using our graphing calculator. And we're going to find the best choice of a potential or potential rational zeros to test. And then number 4, we're going to use the factor theorem to determine if a potential rational zero is actually a 0. If it is, we're going to use long division to factor the polynomial function. Okay, as necessary, we're going to repeat 3 and 4 and what we know about factoring quadratics until all zeros have been identified and the polynomial function is completely factored. Okay, a new piece of paper for me because this is going to take a little bit of paper. fair amount of math going on here, so put on your math cap and we'll get started. Okay, example 1. Lots of math happening here. Okay, find the real zeros of f of x equals, and we have a third degree polynomial, 3x cubed plus 8x squared minus 7x minus 12. Now I want to note something here. Okay, this is the same thing. Okay, this is the same thing as solve the equation f of x, solve the equation, I didn't mean to write f of x, solve the equation 3x cubed plus 8x squared minus 7x minus 12 equals 0. Okay? We want to find what x values are on the x-axis in which the y value is 0. Okay, step 1. Use the polynomial's degree. So step 1, use the polynomial's degree to determine the maximum number of zeros. This is a third degree. The degree here is equal to 3. This tells us a max of 3 zeros. Okay, step 2. So we have three possible real zeros here. As we've discussed a little bit, and we'll get into this in upcoming sections. A third degree polynomial can also have complex zeros. We touched on that in a previous video lection. But it will have 3 zeros. There's a max of 3 real zeros in this. Okay, step 2. This polynomial has integer coefficients, so we're going to use the rational numbers theorem to identify those rational numbers that can potentially be zeros. Okay, so P is the factors of negative 12, the factors of the constant. Well, those are positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 4, positive or negative 6, and positive or negative 12. Okay, the Q stands for the factors of the leading coefficient. The leading coefficient is 3. So the factors of 3 are positive or negative 1 and positive or negative 3. Okay, potential. Real zeros equal positive or negative P over Q, which means we have a lot of them. Positive or negative 1 over 1, positive or negative 1 over 3. Okay? Positive or negative 2 over 1, positive or negative 2 over 3. Positive or negative 3 over 1, positive or negative 3 over 3. Okay, positive or negative 4 over 1, positive or negative 4 over 3. I need another line. Positive or negative 6 over 1, positive or negative 6 over 3, and finally, positive or negative 12 over 1, positive or negative 12 over 3. Okay, let's list these. Okay, so these are plus or minus 1, positive or negative 1/3, positive or negative 2, positive or negative 2/3, positive or negative 3 comes from this one. Well, this is 3 over 3 is 1. We've already counted that one, so I won't write it again. Positive or negative 4. Okay, positive or negative 4/3. 6 over 1, positive or negative 6. 6 divided by 3 is 2. I've already counted that one here, so I won't count it again. Positive or negative 12, and 12 divided by 3 is 4. I've already counted that. So these are the potential real zeros here. We have how many? 2, 4, 6, 8, 10, 12, 14, 16, 18 potential rational potential. They're potential rational, not real. Sorry about that. I made a mistake here. These are potential rational. Sorry about that. I got to fit that in. These are 18 potential rational zeros, not real. I made a mistake there. Okay, step 3. Let's use our graph and find what one of these that we think works. Okay, so I'm going to go into my graph, go into my calculator here, y equals, I'm going to clear what's in there, 3x cubed plus 8x squared minus 7x minus 12. I'm just going to go to my standard window in case it's different, and I'm going to take a look at what's going on. So there's my function. Looks like I can zoom in on the x-axis a little bit. Window, let's go from negative 5 to 5. Let's come in a little bit on the x-axis. Okay. It looks pretty clearly, okay. I'll start on the left side. It looks like negative 3 is a potential rational zero right there from my graph. Okay, so if you'll notice, I'll come back to here, you'll notice I could also use, it looks like negative 1 is a potential rational zero. I'm going to use negative 3. Okay, so step 3, from the graph, negative 3 appears to be a potential rational zero. Okay, so step 4, let's check it, and then let's do some long division if it is. So step 4, if it is, the factor theorem. Okay, the factor theorem. What is f of negative 3? If negative 3 is a 0, then when I put negative 3, and I'll come down a little bit here, make sure you can see the top of the paper, if I put negative 3 into the function, 0 should come out. Okay, and that tells you that it has a remainder of 0, and that means it is negative 3 is a 0. So I'm going to 3 times x cubed, 3 times x cubed, plus 8 times x squared, minus 7 times x, minus 12. I'll put negative 3's inside every parenthesis, replacing the x with negative 3. I've already done this. If you put this in your calculator and do the math, you come up with 0. Okay, so the factor theorem says the remainder is 0. Okay, so we know we put it in. Remainder equals 0. So negative 3 is a 0. So x minus negative 3, right? Which equals, tell you what, let me go to another line because I'm running out of space here. Okay, Okay, so remainder is 0, so negative 3 is a 0. Okay, so x minus negative 3, which equals x plus 3, is a factor. Okay, it's a factor of the polynomial. Okay, so let's use long division to see what is left over. Okay, so x plus 3 can go into our function. Our function is 3x squared, our function is 3x cubed plus 8x squared minus 7x minus 12, and let's do the division. We should get a remainder of 0 because it is a factor. The question is, what is the quotient? Okay, x into 3x squared is 3x squared. Multiply 3x cubed plus 9x squared, parentheses, subtract. And I come up with negative x squared, bring down everything else. Okay, x goes into negative x squared, negative x times, okay, negative x squared minus 3x, parentheses, subtract. Let's see here, this is going to be negative 4x, I hope. Yes, bring down the negative 12. X goes into negative 4x, negative 4 times. Multiply, negative 4x minus 12. Subtract, 0. Okay, lost my sheet. Sorry about that. Okay, so here's it is. I did the x here. Subtracted, I brought it down. I did the 4 here, subtract. I have a remainder of 0. So this tells me, okay, this all tells me, so at the bottom of this sheet, you can see how much work this is taking. This tells me, I'll use the symbol for therefore. Therefore, okay, f of x factors as x plus 3 times 3x squared minus x minus 4. Okay? That's how it factors. Now, the next piece is this factorable? Okay? Is that factorable? So what x solves this? Well, the quadratic formula comes into play here. All right, so I'm going to need another piece of paper to come up with the quadratic formula for this. So I'm going to turn this over, and we're going to look at 3x squared minus 4x minus 4. So we're going to continue. We have to see if this is factorable. Okay, so is 3x squared minus x minus 4 factorable? 3x squared minus x minus 4 factorable. Well, let's go to the quadratic formula. Okay, formula. Okay, and we have x is equal to opposite b, so the opposite of negative 1, plus or minus square root b squared, which is negative 1 squared, minus 4 times a, which is 3, times c, which is negative 4, all over 2 times a. If we do this out, we have 1 plus or minus. Well, this turns out to be, let's see here. What is that determinant? Let's go into here. Second quit. What is negative 1 squared minus 4 times 3 times negative 4. 49. So this is the square root of 49. That's 7 all over 6. Okay, so 1 plus 7 over 6 is 8 over 6, which equals 3/4. And 1 minus 7, negative 6 over 6 is negative 1. Okay, so this is factorable. 3x squared minus x minus 4 factors as x plus 1, there's the minus 1 coming out as a factor, and x minus 3/4. All right, so f of x equals, I'm going to rewrite the function again, 3x cubed plus 8x squared minus 7x minus 12 factors as, okay, the first factor, if you remember, the first factor was right here, x plus 3, which we found up here as x plus 3. Okay, so we have x plus 3. And now we have these two because, I'll come up here a little bit, because this quadratic was factorable into this times this. X plus 1, x minus 3/4. Okay, so we solve this. What are the real zeros? Okay, so solve x minus 3 times x plus 1 times x minus 3/4 equals 0 to find the zeros. And as you know from the zero product property, x minus 3 equals 0, or x plus 1 equals 0, or x minus 3/4 equals 0. So x is equal to 3. I think I might have goofed something up. Oh yeah, I forgot. I made a mistake here. This is a plus 3 and a plus 3. So I got to rewrite this. I messed it up right here. That's a plus 3. So this is a plus 3. Sorry about that. X equals negative 3. X equals negative 1. And x equals positive 3/4. Those are the real zeros of this polynomial function. Now I know what you're thinking. Couldn't we just use the graph? And the answer is yes. Okay, but we're going to see how we're going to need to do this process in future video lectures. But certainly, if we were to go into here, I'm going to pull the function there and get my calculator on the screen. Okay, I'm going to go back and turn it on and pull out the graph. Well, you can see it has 3 real zeros. Okay, what are they? Well, let's go calc our zeros. Okay, let's first go to the far left, and let's put the bounds to the one on the far left, and let's see what it is. So left and right bounds, it's negative 3, which we have, I think I'm down a little bit here, which we have right here. Okay, let's check this one. Let's move to the left to this one. Second calc, the 0. Let's go to the left of this 0, which will be above the axis, the x-axis. Let's go below the x-axis for our bounds and press enter. A 0 at negative 1 right here. Now let's check our third one, which I made a mistake on someplace. It looks like, oh, I did make a mistake. Okay, so let's first go here and you can see my mistake. Notice, not perfect. Let's first check it with the calculator. So second calc, 0. I bet you saw this coming. Okay, it's greater than 1. There's the left bound. There's the right bound. I check it. I get 1.3 repeating. That's 1 1/3, which is 4/3. Well, wait a second. My answer says 3/4. So where did I go wrong? Well, I went wrong up here. 8/6, and you probably saw this, is 4/3. So this should be 4/3. This should be 4/3. This should be 4/3. This should be 4/3. This one should be 4/3. And there is my error, corrected thanks to a double check with the graph. There's 4/3. So there's my mistake. I bet you were probably thinking the last 5 or 10 minutes, he blew it up here. What's he doing? Okay, so there you have it. Let's do a second example. And I'm going to start, I have half of this sheet left. I'm going to start at the bottom of this one. I'll have to move to another sheet of paper. So example 2, let's do the same thing. Okay, the same thing is find the real zeros of f of x equals 2x cubed minus x squared plus 2x minus 1. Okay, let's follow the same pattern. Step 1, degree 3 means max of 3 real zeros. Okay, max of 3 zeros, period, but max of 3 real zeros. There will be 3 zeros. Degree 3 means there will be 3 zeros. Okay, there'll be a maximum of 3 of those will be real. Okay, step 2. Let's use our rational zeros theorem to identify those rational numbers that could potentially be zeros. Okay, so P. I'm going to turn my paper over so I make sure I'm on the same thing. Factors of, okay? I want to follow the same procedures. P. Factors of the constant, which is -1. Oh, how nice is this? Okay, that's pretty simple. Plus or minus 1. Q. Factors of the leading coefficient, which is just 2. Oh, this is getting better and better. Plus or minus 1, comma, plus or minus 2. Okay, so potential. Potential rational. Potential rational zeros equal positive or negative P over Q. So it equals positive or negative 1 over 1, positive or negative 1 over 2. Okay? 1 over 1, 1 over 2. Okay, well that means we're talking about plus or minus 1 and plus or minus 1/2. How many do we have? We have 4. 1, 2, 3, 4. We have 4 potential rational. Rational, again, can be written as a fraction, zeros. Okay, let's go to our graph. Step 3, let's go to our graph and let's pick one that we think is going to work. Okay, I'm going to move this up a little bit so we can see the function and the graph with the calculator. Okay, turn it on. Go to y, clear out y1. Let's put in 2x cubed minus x squared plus 2x minus 1. And I'm going to start with the standard window to see what's going on. Okay, there it is. Honestly, I only see a cross in the x-axis one time. So let's zoom in. We can zoom in between -2 and 2, I think, on the x-axis. -2 to 2. Let's zoom in there. Here it comes. Well, look at that. Now, it appears from the graph that I only have one real zero. You can see it crossing here. It looks like it's probably close to 1/2. Now remember, my potential zeros include positive or negative 1/2. So from the graph, one half looks to be a zero. Okay, looks to be a zero from the graph. Let's use the factor theorem to check it. Okay, so for factor theorem, let's see if it really is using the factor theorem. Now we can also use the graph on the calculator, but we're gonna look at this algebraically because we're thinking about lessons in the future. The factor theorem, if we put 1/2 into the function, a zero should come out. So f of 1/2 is equal to, here's the function, so 2x cubed, 2 parentheses cubed, minus x squared, plus 2 times x, the input, minus 1. I'm going to put 1/2 in here. And then I'm going to pull out my calculator. So give me a moment to slide this up. And I haven't done this yet, which is why I'm doing this. Let's take a peek. I'm going to quit out of here. So 2, and I'm going to write 0.5 in for 1/2. 2 parentheses 0.5 cubed minus parentheses 0.5 squared plus 2 parentheses, so 2 times 0.5 minus 1, fingers crossed, I got a 0. That equals 0. Okay, so that tells me something. Okay, that tells me that I have no remainder. Okay, so this tells me, all right, 1/2 is a 0 because I wound up with no remainder using the factor theorem. So x minus 1/2 is a factor. Okay, another piece of paper. Okay, I'm going to need more room here. So I know that x minus 1/2 is a factor. Let's do some long division. Okay, so I'm going to put x minus 1/2 to find the quotient. My function was 2x cubed minus x squared plus 2x minus 1. Let's do some division. Long division. X goes into 2x cubed, 2x squared times. This is 2x cubed. This is just minus x squared. Oh, I like how that worked. I was worried about the fraction. Parentheses subtract. Negative x squared plus x squared. I got nothing. So this is zeros. Okay? Bring down the rest. 2x minus 1. Because this is zeros. Just zeros. Okay? X goes into 2x. 2 times. 2 times x is 2x. 2 times negative 1/2 is negative 1. Parentheses, subtract, 0. Okay, so what does this tell me? This tells me f of x, which equals 2x cubed minus x squared plus 2x minus 1 factors as x minus 1/2 times 2x squared plus 2. Okay, that's how it factors. Well, hang on a second. This has a common factor of 2. So I can rewrite this as 2 times x minus 1/2 times x squared plus 1. Okay, I can factor that 2 out and make it look even better. Now this is a quadratic. But you'll notice with this, is this factorable? Okay, so what do we know here? Okay, we know that we want to set this equal to 0. This quadratic is not factorable. There's no way to take a real number and square it, okay, and then add 1 to it and get a 0. So this is not factorable. So we know x minus 1/2 is equal to 0, or x squared plus 1 is equal to 0. Okay, well this gives us x equals 1/2. That's a real 0, but we knew that. This gives us x squared equals -1, and that's bringing us back into x equals plus or minus the square root of -1, and if you'll recall, the square root of -1 is I. Okay, so as far as the real zeros are concerned, this function has one real 0. It has 2 imaginary or 2 complex zeros. Let's go back to the graph quickly and take a look at that. Then we'll call this video lecture done. Here's the graph. I'm going to zoom it back out a little bit. I'm going to go back to the window and go back from -10 to 10. And you can see the graph only touches the x-axis in that one point when x is equal to 1/2, which is what we have right here. But there are 3 roots, okay? But there's only one real root. The other 2 roots are imaginary. So a lot going on there, which we're going to continue to play with in future video lectures.